Okay, we'll talk about how to set up a power velocity controller. This is a newly born NextGen controller made for a customer that will be running it at maybe around 10 kilowatt, maybe more, 15 kilowatt on a bike, and that bike will be running a lightning rods motor. Lightning rods drive with the two-stage, I believe. So, and it will be running an IPM motor. So I'm testing this controller with a similar motor, which is also IPM, but a smaller version of it. So I fixed it on this other two motors that I've been using for testing, for creating the load on the controller. And this is not really, but it's not moving, so that's good. Also having a customer's battery that I've been fixing on some issues with. And also I throw in a e-bike. Let's say e-bike. These ones are used for solar, but these are great to be used on e-bikes to as the circuit breakers, right? Obviously, you can. This one is rated for 120 amps and 250 volts, so these are great. So this will be good for setup for this bike, and you normally want to put this on battery positive between the battery and the controller, so it will trip if something like very high current gets in the line, something gets shorted, a motor or controller, so this is supposed to trip. Anyway, so let's go back to the controller. So on this controller we have, let's look at the wiring. Right now we have 82 volts running from that battery, but let's take a look at the wiring. So the wiring, we have Hall sensors, we have phases obviously here, we have on-off wire. Right now it has a jumper wire there, so it's on. And we have 5 volt accessories. You can up to 1 amps to charge whatever USB phone or something like that. So so it's running through the again through this circuit breaker. Always a good idea. And we have this cover open, and we have USB connected. Normally this is not necessary because it has Bluetooth and Wi-Fi. So pretty much all wireless, everything can be set up wirelessly from a phone and also from a watch like this. It's through the Bluetooth. The application is almost ready. It'll be released pretty soon, and these watches will be available and supporting pretty much any VESC controllers that run VESC VESC firmware. Anyway, so that is, we have also control whole throttle connected, whole throttle, and so this side has brakes. This is basically, you would connect another throttle where you can do the variable regen, and you also have a regular throttle, accelerator throttle, and you also have cruise control for this. It has a lot more communications, but this is all necessary for this build. Let's take a look at the tool, a VESC tool. We're running VESC tool just to show how to set it up. And what we'll do is we'll show that there is a wizard that you can run, and this wizard allows you to set up everything pretty much in one shot. However, for this demo we will not be running a wizard because it's too easy, and we will be running each step manually, really just to show what it's doing while it's running the wizard. Anyway, also we can start with the setup input, so basically throttles. So you hit that, click next. It will scan for other controllers on the CAN bus. Obviously we have only one controller here right now, so you would want to select for e-bikes throttle, basically whole throttle. And as you click that, all you need to do to set it up really is that if you have 2 throttles, you just do it like this all the way. Throttle is disabled while you do that, and it will detect lower and upper limits of the throttle. So same will happen with the regen throttle. Right now it's just not connected, so I'll hit apply, and for the regen I'll just set some realistic values just to make sure it will not trigger because the throttle is not connected. So I want to set something higher than what we have here. So, and then I click next. Here, if you have regen throttle, you would select this current no reverse brake ADC. We just have one throttle connected right now, so click that. Right configuration, control type current. That's a preferred method for pretty much all surface vehicles like bikes. Current control feels very natural when you natural response to the throttle. So then we will detect some values here. That's a motor detection. So there's just two buttons that we need to hit on this screen. R and L is resistance and inductance, so we'll just hit that. It warns you that you have to be careful what motor you're running this, what battery, what current you have selected. So we have safe values right now. We have 33 amps for the motor, so it's good. So that's a good sound for detection, and it did update values here and here. Okay, and the next thing you want to hit is flux detection, and here you have to be careful because it's going to spin the motor, so you want to make sure the motor is either a wheel is raised or otherwise disconnected from the drive train. So you click OK. It will spin the motor, and what we'll do is detected some 17.5, and so this is all. I will just hit apply, and we'll hit write it to the motor configuration. So there's application configuration and motor configuration. So we'll just hit that. The last thing we really want to do is just go here and detect Hall sensor. Again, this is all can be done in one shot through the wizard, but I just want to show how to do this manually. I prefer more this method, but what we'll do is just spin the motor a little bit one way and the other way, and what it does is detecting the Hall sequence, and you're expected to get a good result here, right? So okay, I need to apply again here, and I need to write it back to configuration, motor configuration. From this moment, the controller is set up to run the motor. It's all paired to the motor. The other thing you want to check, maybe go here and check how much current you want to put into the motor. And how much battery current. These limits are important actually, so you want to set up according to your battery, you know, how much battery you can have, and how much battery, how big battery you have, and how much current you can output, but also how much based on how much the motor can take, right? So these are good values for this setup right now. You can probably 200 amps even good, but for this test that's enough. So I can test it. You can see that I get pretty good fine control. Pretty good low speed control. Okay, and you can get some more if you're interested. You can get some data here or visual data. So it will show you the duty cycle, amps, other things. All this data is available through the application and let's see, there's tons of other things, but for this video is good enough. And that's the way you set up a power velocity controller. Okay, thank you, bye bye.